Welcome back, Science 7. Today we are continuing learning about rocks and mineral. So let's get this thing started. Last time we learned about pyrite, which is known as fool's gold. As you may see, the color is yellowish copper color. It is quite shiny, so it has a luster properties. So long story short, pyrite has sulfur and iron in it. Dolomite, on the other hand, is carbonated rock. It has a carbonate in it with the other metal, and it does contain quite chunks of different mineral types. So as you can see, minerals grow differently. Some of them has a luster property, some of them is more less, so it's more foggy. Talking about dolomite, they are from sedimentary layers or sedimentary rocks. So as an initial part, let's go through one of your homework questions. What do you think sedimentary rock means? So first thing first, in science, it's a good idea to divide some of the terminology into two sections or more. What is sediment? First thing first, sediment means those are some kind of layers made by rocks, technically small rocks, sand, silt, etc., etc. Sediments are those small rocks, sand, silt, and so on. Gravel, if you will, too. Sedimentary rock means these are included in the rock. So a rock is composed of many different sized particles. Plus, you can find it from sedimentary layers. That's something that I can share. Obviously, your answer can be a little different, can be dramatically different, but it's as long as it's along the same line as what you see down there, that's on the right track. So now let's go through major mineral type. The first one that I'm going to go through is very similar as a previous one, but specifically known as calcite. Like the name suggests, there is a little hint about element that play a huge role. Calcium. So calcite, first of all, it's one of the most common mineral, ladies and gentlemen. So what I mean by common is it's not that expensive. You can find it in many different parts of the world. It includes, like the word suggests, calcite, calcium, carbonate. You may notice some pattern in here. Yes, like the word suggests, if you have some elements that play a huge role as a whole structure of the rock or mineral, then generally scientists name those based on the element that is abundant in that structure. Main component of limestones, if you don't know what limestone is the one that is sometimes used for the lake and others to raise up the pH level. It kind of used to neutralize acid. Neutralize acid lake, people use it. And sometimes it's found in marble. It's used for construction material quite a lot. Is it strong? Not entirely strong, but when it comes to basic structure of the house exterior structure, generally it's used. And as you can see from this diagram, calcite was used a lot back in ancient Greece time and ancient Roman time. As you may notice, a lot of white color that you see over here is actually done by a chemical called calcium. Calcium can be found in seashell structures too. So that's why you can find in nature how easy to find the material. When it comes to this picture, these are what you can see in any place, even in the way to hiking in Rocky Mountain Range. You can find it any place. Limestone. Limestone is made out of one material, and that material is actually calcium carbonate. You can actually find this chemical, the exact same particle, in sculptures too, actually. The one that worked like a chalk. Calcium carbonate can be written as CaCO3 solid. So write down somewhere on your note. The next mineral is known as quartz. Quartz are generally used as a special ingredients for extra layer, safety layer for glasses recently, but a lot of laboratory instruments use it. Some of those advanced level of microscope use quartz in it too. And so as any type of chemical analysis devices in university, they're made out of quartz. Special lens sometimes has quartz in it too. So first of all, you may notice that we have different type of color like blue, purple, pink, all the way around. Know the fact that when it comes to chemical structure, those are all very similar. It's just what kind of additional stuff that is inside of the quartz give you that much of unique coloring afterwards. So when it comes to quartz, it consists of silicon and oxygen. So sometimes we name it as silicon oxide or silicon dioxide, like carbon dioxide, silicon dioxide. It is one of the most useful natural substances too, because it does reflection and it does let some of the light pass through too. So it's a natural filter of the light. It is also used for sandpapers, whetstones, and silica glass for optic material. Like I said, optic instrument has those quartz in it. The thickness and how spread the slide are or lenses are depends on that. Different outcomes will be expected. And these are the examples. Sometimes quartz is used as a fake, not, how can I say, diamond kind of thing, but it does use for very shiny slash foggy type of jewelry. When it comes to optic material, we use quartz. This is something that you may learn before. We call it prism, the one that let the light pass through and then spread it like rainbow. Sometimes you may see this silica gel packet. This is the one that is included in a product that should kept dry, because moistures are absorbed through the silica gel packet, but not to the food material that is inside of the packet. So for example, if you like seaweed, dry seaweed package, generally have one silica gel like this. We shouldn't eat those, of course. When it comes to Felspar, this is a third type. I want you to look at its structure. As you can see, the color is red and it's more angled compared to the others. You don't see a lot of grain, but it's kind of holistic. What I mean by that is most of them is overall pretty spread out. So first thing first, Felspar make up about 41% of Earth's continental crust by weight. So it is quite common, if you will. And this is something that I want to point it out as a little emphasis, if you will. It is crystallized from magma. So what I mean by that is, in order to make this structure, we require extreme temperature. Some of the rocks are made without the temperature. Like what I mean by that is without requiring high extreme temperature like magma. A good example is calcite. Calcite is sedimentary, for example. But felspar come from magma. So when the volcanic activity happen, then whatever the volcano that is erupted, they will cool down, and this is one of those. and it contains aluminum, silicon, potassium, calcium, and oxygen. Something that you may see for the first time is aluminum and potassium, sodium. And the thing is, when it comes to these rocks, quite time to time you can find it at the bottom of the ocean. And the reason is we have some place called trench, which is quite deep under the sea. Kind of like trench is kind of like, imagine Rocky Mountain except it's under the sea. Okay, and it's more stiff. It's not gradual slope. It's almost like a fall. In any case, you can find it underneath because there are quite a lot of volcanoes more underneath the earth. More underneath the sea and ocean. So whenever those come out to the sea, it's gonna cool down instantly. So that's why Felspar can be found easily down there. Why saltwater salty is specifically because of this. We have sodium inside of rock and mineral in this case. So some of the sodium seep out to the sea ocean, and that makes salty water, sodium chloride. When it comes to Felspar, let's look at what it's used for. As you can see, we have a base structures and we have some optic structure, glassware. So when it comes to its main usage, glass play a huge role. They are quite sturdy, in fact. And another, ceramic. When it comes to ceramic vase, those ceramic is actually part of Felspar structure. It's extracted from there. I want you to look at the next type, mica. This look like bunch of stacked cardboard or paper, isn't it? Because it does have bunch of layers. And if you see bunch of layers, that also give you a little hint where the source of this mica is. Mica is name given to a group of minerals that are physically and chemically similar. So if you look at it, can you see it's more gray type, dark gray type, and then it's almost evenly colored compared to the few example before? That means it has a uniformity. All silicate minerals known as sheet silicates are the one that you see, and I like to highlight for that sheet over here because it's a continuous sheet that is stacked up together under high pressure. And they form in distinct layer, as you can see, and they're generally very light, soft, and flexible. So compared to the previous example where it's heavy and dense, this is more usable for our industry. So some of the example, we can use malleability and ductility property of mica, and then we can produce several insulation materials. So it is used for electrical insulator in electronic equipment. It can also be used as thermal insulator and windows in stoves and kerosene heaters on the oven. You can use it for this material. Mica tape electrical insulator is basically the technology that enable us to use for those. The next example is hornblende. Hornblende can be one of the most distinct one out of everything in terms of color. It looked like coal, to be honest. Hornblende is dark colored minerals. It is not the highest grade, by the way. And yes, it is actually found quite often in minor area too. It does vary in terms of composition. I can see that when it comes to example on the left and the middle, it's more pure compared to the bottom and the right one over here. As you can see, it has several other minerals embedded with it. It's quite useful for not expensive material like highway construction. People use it for reinforcement. Railroad ballast, I'll tell you what that is. And dimension stone, which is the one that people use to make a exterior of the building that looks beautiful than the brick. So like what you see in here, as you can see, ballast of the railroad are the filler that you see near the railroad. So those are the one where it's built so that no plants can be interrupted during the any type of passing and going of trains, and generally that minimize the damages somehow. I need to research why. And when it comes to dimension stone, this is what I mean by dimension stone, except it's more calcite that I see. The one that I mentioned is combination of what you can see in this dark hornblade sample that has been stacked, and then we're using that to build a dimension stone. Now hornblende was not a expensive material because of the outlook, first of all. Too, it's not aesthetically appealing, let's put it that way. Although there are a lot of types of properties of rock and mineral, but we're going to look at only a few today. The first one is luster. Luster is a fancy way of referring that things are shiny. So how shiny the metal is, this is a definition. When it comes to second, metallic luster, that means it shine like metals such as gold and silver. And when it comes to description of luster, there are several, but pearly type of luster, so it's kind of like foggy, like quartz example, we're gonna see. There's glassy type, there's a waxy type. Waxy type is more, you can find it from jade, so green jade, green and white jade. Silky type, greasy type, and brilliant type. So these are example of glassy and pearly. It's kind of straightforward if you think about glassy. Most of the time it's transparent, and whether it's a white color or blue color or something, you can see through most of the time. Pearly, on the other hand, is more opposite of transparent. It's foggy. I put extreme example over there, but you cannot see through. So those are the one that I like to put. See through versus cannot. Waxy and silky type. Waxy type, I mentioned to you, it's quite similar as jade situation. Jade is the one where it used a lot quite often, and it comes to Chinese and Asian manufacturers back end. Oh, I don't even know. It was BC and AD. It was ancient China, Japan, Korea time. We generally use those jade for even as a stamp of a royal symbol. So in any case, waxy structures are the one where it's quite turbid and you may have some streak. On the other hand, silky type, can you see it's more evenly distributed, but still you may see a rough type of color that it blended in with others. When it comes to these two, waxy is slightly more transparent compared to silky. Compared to the previous category, greasy and brilliant is quite distinct. It's more about how it would feel. It's kind of hard to say because we are looking at the picture, but imagine you're touching these two minerals. Which one will be more smooth and reflective? Brilliant is more reflective. So a lot of jewelry is coming from brilliant. Greasy, on the other hand, is really turbid. It's more rough surface and so on. When it comes to property of rock number 2, obvious part is color. So the first one is luster property, so whether it's shiny or not kind of time. And the most shining part was brilliant. And the least type can be greasy or waxy, depends on what you call as a most not transparent or shiny part. But in any case, when it comes to color, people first of all identify as soon as you see that. And some of the chemical depends on the color. You know what's inside of these actually. Color can quite vary even within the same material, ladies and gentlemen. Because rock is actually a combination of multiple type of elements that is inside, most of the time bunch of metals. For example, corundum can be white, but it can be red or blue. This is an example of corundum. The last part of the property that we're going to look at is known as streak. Streak is what you can see from this diagram over here. Things are breaking and you can see the line is forming, ladies and gentlemen. So streak is telling you what kind of physical damage occurred, but at the same time some of the streak is not done by a physical damage. It just happened within itself too, especially when it's underneath of the earth, and then it was one of those that come from magma. Maybe it happened during the cooling period too. So streak, it represents the color of powder of the mineral, and color of the streak sometimes is different as the color of the mineral happen, and you can see it from the example in this PowerPoint. So we have homework for today. I want you to read page 371 all the way to 376. All of those are related to properties of rock. We only went through 3 different parts, but there are more. Then I want you to answer question 1 and 2 on textbook page 376.